function of x with respect to x is denoted by I. Here are some examples which we have to solve. Now start with first example. As we have given a function of x which is integrated with respect to x. So in solution I put this integration as a I. Integration of x raised to a plus a raised to x plus a raised to a into dx. As these are terms of x in addition, so we use rule of integration and take integration of each term separate. First term is x raised to a, so we operate integration symbol and multiply this term of x with respect to dx. As we see here, the addition we have given integration of addition, so this addition is multiplied by dx. Now we are going to separate each integration of each term separate. So by multiplying each term by dx, we take its integration. Now second term is the integration of a raised to x dx plus, actually a raised to a is a term of constant. As we know, constant is always take outside integration. So we take a raised to a outside integration. So we get integration of dx. Now x raised to a is a power function. By formula of integration we increase power by 1. So x raised to a plus 1 divided by a plus 1 plus a raised to x is exponential function, have a standard integration a raised to x divided by log of base a plus a raised to a remain as it is an integration of dx is always x. And remember, after completion of integration, as there is a operator or symbol of integration is eliminated, so the integration is complete, so we put constant of integration c. Okay, the first example is solved. Next, second example also I put this integration is equal to I. So integration of e raised to 2x plus 1 upon 1 plus x square. Here we have forgot to put operator dx. Remember, operator is a must to take integration. Now this is the addition again. We separate each term's integration plus integration of second term 1 upon 1 plus x square dx. Now e raised to 2x is a standard integration having coefficient of x is a 2. As we know the note, we put coefficient of x in denominator of integration. So exponential function e raised to x as integration e raised to x. So e raised to 2x as integration e raised to 2x and divided by coefficient of x is a 2 plus 1 upon 1 plus x square is a standard integration as it is a derivative of tan inverse of x. So integration of 1 upon 1 plus x square is always tan inverse of x plus c. Next, third example is I is equal to integration of x raised to 3 by 2 minus cos of 3 by 2x into dx. Here subtraction is given of two terms, so take separate integration of each term. First integration of first term x raised to 3 by 2 with respect to x, which is a power function, minus integration of second term cos of 3 by 2x with respect to x, which is a trigonometric function. As a power function, we know we increase the power by 1. If it is a power is given integer, then we take direct summation or addition. If it is in fraction, like here 3 by 2 is given, so we put it in standard form, that is x raised to 3 by 2 plus 1 divided by 3 by 2 plus 1 minus, actually integration of cos function is here having coefficient of x is a 3 by 2, so integration of cos is always sine. So cos of 3 by 2 x as integration sine of 3 by 2 x, and by note we divided coefficient of x 3 by 2 and put finally constant of integration c. Okay, next, now we move next example. Example number 4. Again I put it as I is equal to given integration of 1 plus cos of 3x dx. Again addition is there, so we take separate integration. First we have to integrate 1 with respect to x plus integration of cos of 3x with respect to x. As 1 is a constant, you may take it outside integration, or we know integration of 1 with respect to x is always x. So I take direct integration x plus again cos of 3x. Here function is a cos, but having coefficient of x is a 3. So by taking using note, I take integration as a cos 3x divided by 3 plus. Next, integration of sec square x plus cosec square x into dx. Again, addition of two terms, take separate integration of each term with respect to x plus integration of second term cosec square x with respect. Remember how to write integration of term. I put first symbol, then term of x, and then its operator dx, as these are the function of x only. So integration of sec square is always tan x. We know derivative of tan is a sec square x, so integration of sec square is a tan x. Similarly, derivative of cot x is a minus cosec square, but we have to find here integration of cosec square, so minus take was transfer on left hand side, and we get integration of cosec square is always minus cot of x, and plus c is a constant of integration. Next, I is equal to integration of sec of x plus sec x into tan x minus tan of x with respect to x. Here three terms are given, so we take integration of each term separately. So integration of first term sec of x dx plus integration of sec x into tan of x dx and minus integration of tan of x with respect to x. Now integration of sec x. Sec x has a derivative sec x into tan x, and sec x has the integration log of sec x plus tan x. So I take here integration of sec x is a log of sec x plus tan x. Plus next, integration of sec x into tan x. Actually sec x into tan x is a standard integration which has this integration sec of x. As here is a product, we know in a derivative if the terms are in product, then we should apply product rule, but there is no rule for product integration of product. So we use here only, we can use here only standard formula, as integration of sec into tan x is always sec of x, as derivative of sec x is a sec into tan of x, and minus integration of tan of x, integration of tan of x is a log of sec of x, and we put plus c as a constant of integration. And now we move to last example. I is equal to integration of 1 upon x minus e raised to x plus sine of x by 2 with respect to x. Again three terms are given, so first term is 1 upon x integrated with respect to x, minus second term is e raised to x integrated with respect to x, and plus integration of sine of x by 2 with respect to x. Now 1 upon x has integration log of x minus e raised to x as integration e raised to x, plus actually here is a function is a sine, but x coefficient is a 1/2, as integration of sine is always minus cos, so integration of sine x by 2 is a minus cos of x by 2 divided by coefficient of x 1/2 plus c.